Hello! In today's lecture, we will be covering an introduction to exponent properties. Recall that in this current class structure, we're trying to move lessons to videos at night, freeing up the day for more questions and extended practice. So as you listen to today's lesson, please remember to take notes and to write down any questions you have for the beginning of the class tomorrow. So we'll start today with just an exponent definition. So exponents are really just a simplification of multiplication notation. So it's just a way of writing x many iterations or a many iterations of x multiplications for x to the a. So in this case, we have them both as variables, but recall that, these could be anything. Right? This could be 2 to the 3, or 3 to the 9th, or 3 to the a. You could still have variables in exponents. So we're going to cover a few laws today, which will just give us the basics for beginning to work with exponents. So the first law we're going to cover is multiplying exponentials. So if we look at our multiplication definition, when we multiply exponents of the same base, so this base is what we are multiplying, and this is the exponent. When we multiply exponents of the same base, we just add their exponents. So we're going to do an example. So this is 3 to the 4th times 3 to the 3rd. So both of these terms have base 3. And all we have done here is apply the definition, right? So 3 to the 4th is just 3 multiplied by itself 4 times, and 3 to the 3rd is 3 multiplied by itself 3 times. If we use the associative property, we can get rid of these parentheses, and we should recognize that this is just 3 to the 7th, right? We're multiplying 3 by itself 7 different times, which conveniently gives us our exponent or multiplying exponential law, right? Whereas our exponent is just the sum of the two exponents we're multiplying. So dividing exponentials, similar to multiplication, converts whatever our exponent operation is into a subtraction problem. So when we were multiplying before, we were adding. Now that we are dividing, we are subtracting our exponents. So we can just create a fraction and see this through an example. So we have 4 to the 5th here over 4 to the 3rd. So once again, we're just going to apply the definition. So in our numerator, we have 5 4s. In our denominator, we have 3 4s, which will allow us to cancel, right? Since all of these terms are bound by multiplication, it means we can cancel them, which just leaves us with 2 4s or 4 squared, which is the same as our initial fraction, where we're just subtracting our exponents. So the exponents of exponentials, so raising an exponential to an exponent, functions a little differently. In this case, we are multiplying the actual exponents to generate the conversion. So similarly here, we can actually take the definition of the squared exponent here. So we have 5 to the 3rd, which is squared. So step 1 is just getting rid of this parentheses. So we have 2 5 to the 3rds. We're just using the definition here, right? We have 3 5s in each line, which, given its multiplication, we can get rid of this association, which leaves us with 5 to the 6th, which is conveniently just the multiplication of our two exponents. So the next two concepts, we're not going to go over an example, but you may encounter them tomorrow when we're doing practice. So it'll be necessary just to give you the definitions. So when we have negative exponents, this is actually shorthand for just saying it's an exponent in the denominator. So we actually saw this, right, with division, right? So when we were subtracting exponents, when we had division, we essentially were multiplying exponents where one was a negative exponent and hence was in the denominator. And last would be fractional exponents. So fractional exponents yield roots where the denominator of the exponent is to what root degree are we taking the base to the numerator. So in this case, x to the a over b is the bth root of x to the a. And that's all we have for today. Please remember to write down and bring your questions to class. We'll cover those first things first, and then we'll jump right into practice. Thanks.